All right, good. All right, so our last one today, 5F, finding areas by integration. And the first thing it says is areas and definite integrals are closely related, but they are not the same. And you say, but Mrs. Ralph, you told me that when I integrated, I'm finding the area. I did. But the thing we have to be careful of, yes, we are finding areas, but if I have a curve like this one and I integrate between minus a and a, on my integral, if I just, my normal integral sign, like this here, minus a and a, I'm going to get 0. The value of that integral sign is 0 because I have a positive area and a negative area that are cancelling each other out. But the area of that is not 0, is it? The area would be 2 lots of whatever one of those bump things are, right? So if you are given a question where it says, oh, let's just evaluate this integral, then yes, the answer is 0. But if it says I need to know what the area is, I have to consider what the graph looks like and go, there's a positive bit of area, there's a negative bit of area. I have to compensate and actually get a real number that represents the area of that curve. So you can see the slight little difference. Yes? Yes, you can see the difference? If you're told to integrate it, it would be 0, but the area, I have to make one of them negative, bring it up so that I can get a value for the area of that graph. The process is the same, okay? All right, so when we are finding an area, we're going to be using integrals to find areas of the regions. The first thing you should always do is draw a sketch of the curve. Unless you know it really, really well in your head already, you want to draw that sketch so that you can see any intercepts, any parts that are positive or negative. If you have 2 graphs on them, we're going to do harder ones of these later. We're going to have 2 graphs. They're going to have points of intersection even. You need to find all those important points first. Then you're going to find the integrals. It says create and evaluate the necessary definite integrals. Integral or integrals. There might be 1, there might be 2 or more. And finally, you'll write a little conclusion where you're possibly adding those 2 things or 3 areas together to get the total area at the end. Okay? So it says, remember, regions above the axes are positive, below the axes are negative. All right, so here's our first one. Find the area of the region bounded by the curve y equals 9 minus x squared and the x-axis. Okay, so first thing I had to do was draw it. If I'm going to draw this, I need to factorize it. So this factorized is 3 minus x, 3 plus x, which gives me the zeros are at 3 and negative 3. So I'm going to draw it over here on the left side at negative 3 and positive 3. They are my x-intercepts. Where is my y-intercept? 9, good, just this number here. It's an upside down parabola that's been moved up 9 places. So here it is at 9, and it looks like that. Okay, I am trying to find this area. Okay, good news. It's all above the axes. That's a great start, which means I don't have to worry about any little negative bits. So I'm going to write the full word for area. I get nervous sometimes just writing capital A because then you've got things like sine rules and cos rules that use capital A's and can start getting confusing for some people. So I'm writing the full word, area. Will be the integral from negative 3 to 3 of my function, which is 9 minus x squared, and I'm integrating with respect to x. Now, I can integrate that straight away from there, but just because we can, there is a little shortcut that we can do. If the graph is even, which this one is, if it's symmetrical across that y-axis, I could halve my integral. I could go from just 0 to 3 and times all of that by 2. That way, it's just a little bit nicer when you're subbing things in, because 0 is always a nice number to sub in. And you just got to times the result by 2. Okay? Yeah? All right, so let's evaluate that integral. I leave the 2 at the front. Integrating 9, I get 9x. And then minus x cubed over 3. Close the square bracket between 0 and 3. Now I'm going to sub in. The 2 is still going to sit at the front. I'm going to keep my square bracket there. I'm going to have 9 times 3 minus 3 squared over 3. Then I minus and I sub 0 into everything. But the beauty of subbing 0 in is that everything is 0. Yeah. Yeah, thank you. Sorry. Yeah, I did. That should be a 3. Thank you. Okay, then type it all into your calculator. Did we get a result? Do you want me to tell you the result? 36. Charlotte got it. Good job. 36. Now, because, no, we got it, but there's just one more bit. Because we are told that we are now definitely finding areas. Areas must have units. Okay, centimetre squared, metre squared, kilometre squared. Trouble is we don't know if these are metres, whatever. So we just call them units. Now, there's a couple of different ways you can write that. You can write the word units and put a little squared on it, because that's like we do metres squared, so it's a unit squared. The examples in the textbook put square units. They actually write the whole thing out in words. That's painful, take you a long time. Or you sometimes just see U squared, units squared. Okay, so any of those 3 options to indicate that you put the units on there. All right, question 2. Find the area of the region bounded by the curve x squared minus 4. It's a parabola again. The intercepts of that parabola, this would be x minus 2, x plus 2 when I factorise it. So my intercepts are at minus 2 and plus 2. So here is my sketch. Minus 2 plus 2. Y-intercept is negative 4. Great. So I've done step 1. I've drawn the parabola. And this time the area that I want from my curve to the x-axis is below. So when I write my integral down, I'm going to be integrating from minus 2 to 2, or I could do double from 0 to 2. Both going to give you the same result. I'm going to expect to get a negative answer here. Now, do we want to do the double part again, or do you want to do it this way this time? You want to do this way this time, just to see it's the same? Oh, you do the 2, and Dave wants me to do the other way. Okay, so I'm going to do square brackets. I'm going to add 1 to the power, divide by the power, and then minus 4 is going to gain an x from minus 2 to 2. Then I sub in, first of all, the 2. It'll be 2 cubed over 3 minus 4 times 2. That's the first one. Then I minus, sub the minus 2 in. So it's minus 2 cubed over 3 minus 4 times minus 2. So you can see why having one of them as a 0 means I don't have to do that whole second bracket there, because that'll just become 0. Have you done it yet, Lewis? Should have been faster for you doing the shorter method. Okay, so you put that in your calculator and you get negative 10 2/3. That's what the integral is. That is the value of the integral. But the area of that is just a positive 10 2/3, which is why we need our step 3. Remember the 3 steps? First step, draw it. Second step, do the integral. And the third step is just write a little sentence that tells me what the actual area is. Okay, so this one really needs that, because it says at the moment it says it's negative. So I'm just going to go, therefore, the area is a positive 10 2/3 units, or U, or square units at the end. Whoa, there's a big line there that shouldn't be there. Okay? All right, next page. Let's make them a little bit harder. Question 3. All right, so question 3. Sketch the cubic curve showing the x-intercepts. It's already factorized, which is wonderful, because that would be a lot more work if it wasn't. So straight away we can read off the zeros. We get x equals 0 from the one at the front. We get -2 from the first bracket and +3 from the last one. That means, here's my sketch. So -2 over here, and it goes through 0 and 3 over there. So, which way does, yep, show me, Joanne. Where are the arms going? Oh, is it high on this side or low on that side? Oh, good. I was worried you were going the other way. Yes, good. Positive x, positive x, positive x. Because all the x's are positive, it's a positive cubic. Positive cubics go that way. So it's going to come down like that. And there's my cubic. You can always sub in a number. You can sub in 1, for example, and it will give you a negative down here to tell you that part's below. You can sub something in if you forget which way the arms go. Okay, I am trying to, actually no I'm not. That's all I had to do for this one. There it is. I want that bit and that bit. There's the area. It says part B, shade the region enclosed by the x-axis. That's what I just did. And I want to find the area of that curve. Small problem. At the moment, my equation is all in brackets. Knowing I have to integrate it, I can't integrate it in that form. So over here, let's just go y equals and expand everything out. I'm going to leave the x and I'm going to expand the 2 brackets first. So x times x is x squared. I have x times -3, so -3x. 2 times x, and then 2 times -3 makes -6. Now timesing my other x in would become x cubed. Let's combine these 2 middle terms. So -3 plus 2 is -1, but times the extra x would be -x squared. And then -6x. All right, that's handy because now let's do our integral. Now we know we have 2 sections. From -2 to 0 is a positive area. It's above the axis. But from 0 to 3 is below and will be negative. This cubic, those 2 areas are not the same size. This is not symmetrical here. So I have to do those 2 integrals separately. Okay, so first of all, I'll do the above. Or I'll say area above. Area above is going to be equal to, and I will integrate from -2 to 0 of the x cubed minus x squared minus 6x dx. Okay, integrating it, I add 1 to the power, divide by the power. The x squared, I add 1 to the power, divide by the power. And the -6x, adding 1 to the power, become x squared over 2, so -3x squared, between -2 and 0. Okay, now I have to sub in. First thing I sub in is 0, but that will be 0, 0, 0. So 0 minus, sub the -2 in. And you've got to be careful, -2 to the power of 4 over 4, minus -2 to the power of 3 over 3, -2 in brackets -2 squared. Just be careful typing this stuff in. When you have even powers, the minus signs aren't important. Okay, you can just type that in as 2 to the power of 4 and you'll get the correct answer. But odd powers, remember, will stay negative. Ah, yeah. Oh, man. Thank you. There we go. 3. All right. What did it equal? Tyler's going to get it. 6 negative? Did you say negative? This is the above one. Did you put the minus in front of it? So, yeah, 16 over 3, or in other words, 5 1/3. Yes. Okay, now we want to do the area below the axes, which we're expecting this one to be the negative one. We are integrating the same thing again, which means we already know what the integral should be. But this time it's between 0 and 3, the negative part. So just look back up here. That is our integral already. So just copying that part down again, just got different numbers on the end. Okay? So x to the 4 over 4 minus x cubed over 3 minus 3x squared between 0 and 3. So you sub your 0 in, sub your 3 in. 3 to the power of 4 over 4 minus 3 to the power of 3 over 3 minus 3 times 3 squared. And it would be minus 0, because all the other ones will be zeros. Anyone zoom ahead of me and get that already? Not yet? It is negative 15 3/4. All right, we found the area above, we found the area below, and we drew the sketch in part A, but we're after the total area. So the total is going to be the 5 1/3 plus, take the minus sign off that negative one, plus the 15 3/4. So that is 21 1/12 units squared. Part C. We already know why this is going to be wrong. I hope we do. It says find, well, not wrong, but different. It says find the integral between minus 2 and 3 of, this is the same equation, just it's factorized version, remember? Find the integral. So this is the difference in the two questions. If I tell you to find the area, you've got to split up the positive and negative areas. But if I just say evaluate this integral, I'm going to get a very different answer because it's going to subtract that negative one off. All right, let's work it out. Pretending that I don't know or don't care about the negative part, I'm just going to integrate normally between minus 2 and 3. The expanded version, so that's the x cubed minus x, what was that, x cubed? Yes, it is squared. Yep, I've got to look back to my thing. Minus 6x, that's what's it. Okay. We already know what the integral is. It's x to the 4 over 4 minus x cubed over 3 minus 3x squared. And we're subbing in the 3 and the minus 2. So subbing in the 3, we get 3 to the power of 4 over 4 minus 3 cubed over 3 minus 3 times 3 squared. Then minus, sub in the minus 2. Minus 2 to the power of 4 over 4 minus 2 to the power of 3 over 3 minus 3 times minus 2 squared. Close bracket. Can you tell me the answer without actually typing that in? I will scroll back so you can see those numbers again. It's not 21. No. It's these two added together with that minus sign in it. So it's a negative 10 5/12. Because the integral itself doesn't know that I've got to actually make that negative part positive. So it just says I've got negative part, positive part and negative parts, and puts the two things together, which is why they're not equal if you've got those two different sections, Lily. Oh, for this, yeah, we could have done that for this, I guess. Yes, that's okay. All right, it does say explain why. So this integral represents the difference of the two areas and is negative because the area below is larger than the area above. No, we're going to make it. Question 4. We're going to make it. 2 pages left. We can do this. Question 4. Show that y equals 4x minus x cubed is an odd function. Okay, why would we do that? We'll ask that question in a minute. But how do we show that something is an odd function? Who remembers? Yes. We better call it f of x first. So if f of x equals 4x minus x cubed, putting it into function notation, we want to sub in f of minus x and see if we can get minus f of x. If you get the exact same thing when you sub it in, it's even. If you have to bring a minus sign out to get the same thing, then it's odd. We want the odd. So subbing minus in, we have 4 times minus x minus x cubed. That makes minus 4x. The minus x cubed is still negative, but with the other negative there, it becomes positive x cubed. So it's not the same as the original, but if I bring a minus sign out and I get 4x minus x cubed, if I bring a minus sign out and this part in the brackets is the same as the original, then that is the definition of an odd function. So I write down here that is equal to minus f of x. I started with f of minus x, I show my working out, and I get to minus f of x, which means I can say, therefore, this is odd. This is an odd function. Now that is helpful to know, because if I'm trying to find areas of things, if it's odd, that's going to tell me that certain bits of areas are going to be the same, hopefully. Let's have a look at part B. Using part A, find the area between y equals 4x minus x cubed. So I need to sketch it, which means I need the zeros. I'm going to factorize it. So bring the x out, and I get 4 minus x squared. Then the 4 minus x squared is a difference of 2 squares, so factorize further, and we get x, 2 minus x, and 2 plus x. Good, I can hear someone doing this. Well done. So my x-intercepts, or my zeros, are at x equals 0, 2, and minus 2. And that means my graph is going to look like this. So we've got minus 2, 0, positive 2. It's a cubic because that x power 3 is the highest power, but there's negative in front of that cubic. So instead of the cubic having arms going that way, they're going to go that way. So it's high. Are you laughing at me with my arms? We're going to go down this side, and it will be low at the positive end, positive values. All right. The area we are trying to find are the 2 little parts in here that are going to the x-axis. And because it's odd, those 2 things are exactly equal. If I just integrate between negative 2 and 2, what would I get? 0. Excellent. But that's not the area. So if I want the area, I'm just going to choose one section. Now, me personally, I like positive sections of area. It's a little bit nicer. So I'm going to go between 0 and 2 of my 4x minus x cubed, and I'm going to double it because there's 2 of them. This negative bit here is the same size. Okay, so now I integrate. Leave the 2 out the front. Add 1 to the power makes 4x squared over 2, which would become 2x squared. X cubed, add 1 becomes a power of 4 over 4, between 0 and 2. Leave the 2 out the front and sub in. Subbing in 2, we get 2 times 2 squared, minus 2 to the power of 4 over 4. And then we would go minus, sub in 0, but that's just 0. Everything's just 0. Then calculate, and I'll just tell you because I know we've done a lot of theory today. So that's 8 units squared. All right, the very last thing that we need to think about, little new bit, there's more little bit of new stuff still here to do. It says note, so far we have only looked at integrating with respect to x. It is also possible to integrate with respect to y. This will allow us to find a definite integral, or the area that is between the curve and the y-axis. Right? So instead of finding our curve and always going from your curve down to the x-axis to find the area, if you're integrating the y, you might have a curve out here and you're going that way to find the area going across to the y-axis instead. That means, though, if you're going to do that, that we have to draw it as per always draw it. You need to create your integrals, but your integrals will be in terms of y. You have to make sure your equation is in terms of y, which may mean you have to rearrange it. It also means that the numbers that are on your integral need to be the y values of your graph, not the x ones. You're subbing in y values. Remember that areas to the right of your Cartesian plane will be positive. Any areas if you're on the left side, if your graph's on the left side, then it would be a negative area. And then write a conclusion where you put your areas together at the end. Okay, so there's 2 questions over here. One is a normal going to the x-axis, and then one goes to the y-axis. So question 5. Find the area between y is equal to x squared minus 4 and the x-axis between 0 and 2. Okay, so it says x-axis. So factorizing, I get x minus 2, x plus 2, which means this lovely parabola has zeros at minus 2 and plus 2. The y-intercept would be at negative 4. Oh, that was a bit wobbly, but it looks like that. We only want the area between x equals 0, which is my origin, and 2. So it's only that little part in there, not the whole bottom, just between 0 and 2. So this is what we're used to. This is just x going to the x-axis. So integrating between 0 and 2, x squared minus 4, and we're integrating with respect to x because we're going to the x-axis. I integrate it and I get x cubed over 3 minus 4x. Sorry? No, because I only wanted between x is 0 and x is 2, I only wanted that part. All right, sub in your numbers. So it's 2 cubed over 3 minus 4 times 2. And then you go minus your 0. So everything's 0 there. And that one is minus 16 over 3, which we had something similar to that before. But that means that the area is a positive 16 over 3, or 5 1/3 units squared. Now, interestingly enough, if I wanted that same little chunk of area and I went to the y-axis, I should get the exact same result because it's in that lovely little groove there. It would be the same area either way that I went. But this next question is set up that I have to go to the y-axis. Okay, it says find the area between this curve and the line y equals minus 2 and y equals 6. So just like before, I need to know what this looks like. It's y equals x cubed. That's our most basic cubic, which starts at the origin and gets really steep that way and then goes down that way. But it says that I want from y equals -2, all right, -2 can be here. I'm going to go dot, 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 and that'll be that part in there, from the y-axis over to my curve, all the way up to y equals 6, okay, y equals 6 is going to be up here, and again, from that y-axis, I want to go across to my curve, and I'll be wanting that bit of area in there. So there are 2 bits of area. This big chunk on the right will be a positive area. The little chunk on the left will be a negative one, and I'll have to add the 2 things together. The other thing that I have to worry about is because I'm going to the y-axis, my equations and everything has to be in terms of y. So this equation, y equals x cubed, I need it to be x equals x by itself. What would it be? Y to the power of a third, cube root, which is the same as y to the power of a third. The power of a third we can integrate, so fractional power is better. Okay, so let's do the area above first. Oh, well, maybe area above is probably the wrong term when we're sideways. The positive part. Okay, I've got to put a big positive sign there. Okay, the positive area. That will be the integral from 0 to 6. I'm using the y values on my y-axis. 0 to 6 is those y values. I also need my y equation, so it's y to the power of a third. And I'm integrating the y, so it is a dy, not a dx. Okay? Integrating, we add 1 to the power, which becomes 4 over 3. Dividing by the 4 over 3 means we'll flip that upside down to be 3 over 4 between 0 and 6. And then we sub in. So 3 times by 6 to the power of 4 over 3 over 4 minus 3 lots of 0 to the power of 4 over 3 over 4. That whole second fraction is really just 0 though. And that equals, I used the old calculator. It wouldn't give me an exact answer. I wonder if the new ones will. I should try. Didn't, no. So 8.18 to 2 decimal places. Had to round it. Okay, now I want to do my negative area or area below, which means I'm integrating from -2 to 0. Smaller number on the bottom, remember, -2 to 0 of y to the 1/3 dy. So the integral part is the same. When I integrate it, I get the exact same thing, y to the 4 over 3 over 4 over 3, which I flip upside down to be 3 over 4, between 0 and -2. And subbing in 0, we will get 0. Subbing in -2, we get minus from my integral, then 3 minus 2 to the power of 4 over 3 over 4, which is -1.89 to 2 decimal places. I have evaluated both of my integrals, but in the very last bit, I then need to write down a conclusion or a total area statement. My total area will be the positive part plus a 1.89. Make that a positive. We don't want to subtract it off. We want to add those 2 areas together, which is 10.07 units squared. We made it.